Okay, so in this section, we are going to talk about fractions 1.2. Another way to say fraction is rational, a rational number or a rational term. All right, so it's just a fancy way of saying fraction. So they interchange this word. And so in fraction form, we have something like A over B. Okay, something concrete that we can represent A over B by is 1/2, right? 1/2, or 3/4, or 5/6, right? So that's in fraction form. And as you know, the numerator, the top is called the numerator, and the bottom number is called the denominator. Okay, and sometimes the lowest terms. They'll say reduce this in lowest terms. So for example, if we have 15 over 25, we find a common factor between them and then reduce it by that and divide by that common factor. So in this case, 5 would be a common factor between them. So 15 divided by 5, right? Um, will give us 3, and then 25 divided by 5 will give us 5. Okay, so we can reduce 15 over 25 to 3/5. Okay. Another term we should know or be familiar with is the greatest common factor. All right. So that's the GCF, greatest common factor. So, for example, if we have, say, 12 and 18, and we break those down to their factors, we'll have several of them, right? So, for example, for 12, that would be like 1/12. Those are the factors of 12. Another one would be like 2/6 or 3/4. Okay. So those are the factors of 12. And then we do the same thing for 18. So the factors of 18, of course, is 1 and 18, 2, 9, and then 3/6. And what you want to do is you want to find the greatest common factor. All right. So even though they have one in common, right? They have two in common and they also have three in common, but that's not the greatest common factor between them. The greatest common factor is 6. All right. So you want to find, so when asked what is the greatest common factor, it would be 6 for both 12 and 18. Okay. Now, reducing to lowest terms is very similar to when they say simplifying fractions. Okay. So when they say simplify fractions, you're basically going to do the same thing as you did here. All right. So if we have, say, 20 divided by 8, okay. Um, Another way to do this is, well, I know that 4 is a common factor between the two. Okay. So I can divide by 4, or another way to look at it is I can multiply by 4. So I can do, like, say, 5 times 4 on top and then 2 times 4 on the bottom. Okay. And so the fours here can be reduced or canceled out, I should say. And then we're left over 5/2. All right. So that's another way to interpret this. Okay. In regards to simplifying fractions. Okay, another term we should know is called multiplicative inverse. Multiplicative inverse. Okay. Or sometimes we call it just reciprocal. Okay. So the definition of this is the product of a number and its reciprocal is 1. Okay. So what do they mean by that? So for example, if we have, say, 3/4, okay, the multiplicative inverse or the reciprocal of that is just, you just flip it, correct? So when you flip it, it'll be 4/3, right? Well, when you multiply the two, okay, so when you multiply fractions, you multiply directly across. So 3 times 4 will give me 12, and then 4 times 3 is also 12. And 12 divided by 12 is going to give me 1, okay? So the reciprocal of it, when you multiply by the reciprocal of it, the outcome or the product of it is equal to 1. Okay. So another example would be like, so 5. Well, it's just 5. It's not in fraction form. Well, technically, 5, I can rewrite this as 5/1. Would you agree that 5/1 is the same thing as 5? Yes, it is, right? Because 5 divided by 1 is 5. All right. So if you just have a number like this, you could always rewrite it as 5/1. Okay. And then the reciprocal of that, or the multiplicative inverse, is just 1/5. When you multiply the two, you get 5 times 1 on top, 1 times 5 at the bottom, and you get 5 divided by 5, which is equal to 1. Okay. Now this goes along with what I just mentioned when you're multiplying fractions, so multiplication. Okay. So when you're multiplying fractions, as I mentioned here, if you have 3/4 and you multiply by 4/3, you just go directly across, and then you just divide your whatever you have for the numerator and the denominator. So in variable terms or in general form, it would be like A over B, okay, multiplied by a different fraction, C over D. And then again, when you multiply fractions, you multiply directly across. So A times C is AC, and then B times D is BD. Okay. Another, example or a concrete example would be like 3/4, and CD might be, let's say, um, 5/9. Okay, because they're all different numbers. So then when I multiply this, that gives me 3 times 5 is 15, and then 4 times 9 is 36. Okay. And if I can reduce it, great. Right? So can I reduce this number? I can, right?
You could reduce it, I
Yeah,
believe.
so the greatest common factor between them is what? Probably 3, right? So I can divide this by 3 and then divide the bottom by 3. So 15 divided by 3 is 5. 36 divided by 3 is 12. So this would be our final answer. Okay. So the next one is division. All right. So dividing fractions. So division. Okay, so division, right? So one way to describe division is, or represent division is A over B divided by C over D. Okay, so what I like to tell my students is that, letters can be confusing. So maybe let's do something concrete. A concrete example would be something like, say, 3/5 divided by, um, sorry, 3/2. I have 3/2. 3/2 divided by 6/5. Okay. Now, does anybody remember what we do here when we're dividing fractions?
Do we go across?
When we multiply, we go across.
Okay.
But this
So if
is
we divide,
dividing. So what do we do? Remember?
Is it
Exactly
more
right.
so defined than just the fraction itself?
Yeah, so remember when we're dividing, we want to keep the 3 over 2, right? We want to keep this one. And then what happens to the division sign? This is going to turn into a multiplication sign, okay? And then this one, we're going to do the reciprocal. We're going to flip this one, okay? We're going to flip it, okay? So we're going to keep it, and then we're going to change the division to multiplication, and then we're going to flip the last one. So in this case, it'll be 3 over 2 multiplied by 5 over 6, okay? And then we just go directly across. So that's going to give us 3 times 5, which is 15, and then 2 times 6, which gives us 12, okay? And then again, I can reduce this, all right? So I can divide the top by 3 and then divide by the bottom by 3. So that's the greatest common factor between them. So the 15 divided by 3 is 5. 12 divided by 3 is going to give me 4. So 3 over 2 divided by 6/5 is equal to 5/4. Okay. So again, I like to, when I see something like this, I'm like, okay, let's go back to what I know and let's just do, concrete examples for specific numbers for the variables. And then what I've done here, I can, um, do the same thing to just the variables. Okay. So in this case, um, I have A over B divided by C over D. So that means I'm going to keep the A over B. And then the division sign, I'm going to change it to a multiplication. And then I'm going to flip the C over D to become D over C. Okay. And then when I multiply fractions, again, I go directly across. So A times D is AD and B times C is BC. Okay, so again, this one we'll be doing adding or subtracting it. You can do both. Okay, so we're adding or subtracting with like denominators. Okay, and then adding or subtracting uh, with unlike. Okay, denominators. Okay, so in this case, in order to add fractions, you have to have the same denominator, correct? So if I have, say, A over B or A over D, okay, in order for me to add this, I have to have the same denominator. So this has to be D as well. So A over D plus C over D, okay? So that's going to give me A plus C over D. I keep the denominator the same, but I add the numerator. So for example, if I had 3/5 plus 4/5, okay, I can add them because the denominator is the same. Okay, the denominator stays the same. I don't do anything to it. I don't do 5 plus 5. I keep it the way it is. Okay, and then I just add the numerator 3 plus 4, okay, which gives us 7/5. All right. Now, same thing for subtracting, right? So if I have A over C minus C over D, right? It'll just be A minus C over D. Or if I had say 17 over 12 minus 11 over 12, 17 minus 11 divided by 12. Well, that's going to give me 6 over 12, which reduces to 1/2. Okay. So again, I can do those things because the denominator is the same. I don't have to do anything fancy or anything like that. All right. All right. So again, as I mentioned, what gets tricky for people is when we have unlike denominators. So again, I like to do the general form. So um, so we have say A over B plus C over D. Okay, we want to add the two. So if we have say 3/4 plus um, say 7/10. Okay, and I want to add those two numbers or two fractions. I need what? I need a common denominator. Okay, but in this case, I want the least common denominator, right? The LCD. Right, the LCD is the least common denominator. Okay, so in this case, what's our LCD? We have 3/4 plus 7/10. What's going to be the LCD here?
The least common would be 4, since it's the lower number.
No.
Oh, no.
Remember, the 4 has to go into 10 evenly. Or I should say 10 goes into 4 evenly. And that's not the case, right? So, um, yes, 20, right? 20 would be your least common denominator because, oops, I will do this later on, but if I multiply 10 by 2, that will give me 20. And if I multiply 4 by 5, that will also give me 20. So one way to look at it is you can do multiples of 4, right? So you can do 4, 8, 12, 16, 20, right? And for 10, you can do 10, 20, 30, 40, right? So it's in going by tens. So in this case, then my least common denominator between them. Now I can keep going here as well on the top, right? It'll be like 24, 28, 32, 36, and then I put dot, dot, dot there. And then you can get 40 as well. So that's another denominator or another factor that they have in common, but that's not the least common denominator, right? Because you can multiply 4 times 10 and get the denominator that way. And you can do that, but you have to do a little bit more work. And it gets pretty complicated when we have more complex rational functions. Okay. So you want to make sure or want to get at least the least common denominator so you don't have to do more work, in the process. Okay. So again, they both have 40 in common, right? So that's a common denominator between them, but they also have 20 in common. And 20 is going to be the least common denominator. That's what I would choose. Again, you can choose 40, that's fine. But again, when we do something more complex, it's gonna add more work to us. And a lot of times students end up getting it wrong because it's just more involved. Okay. So in this case, our least common denominator is going to be 20. So what do we do with that? So that means then our new fraction has to be 20 out of 20. Because remember, in order for us to add fractions, we have to have the same common denominator. So in this case, then what do I need to multiply the 4 by to give me 20?
You'll multiply the 4 by 5.
5, good, right? But what I do on the bottom, I must also do on the top. I can't just multiply the bottom by 5. Because if I do, then it changes it. 3/4 is not the same thing as 3/15, right? They're not equal. I have to have, what I do on the bottom, I must do on top. All right. So 15 over 20, okay, is the same thing as 3/4, but 3 over 15 is not. So be careful of that. That's a common mistake students make, is that they only multiply by the bottom. You have to do the top and the bottom because it's like multiplying by 1, right? I haven't changed anything. this thing is still the same thing as 3/4. Okay? So, but I'm just rewriting it so I can add the fractions. All right. So in this case, 5 times 3 will give me 15. All right. And then how about here on this side? What's that going to be? What do I multiply this by? 2. Good. Right. So multiply 2 over 2. So 10 times 2 is 20, and then 7 times 2 is 14. All right. So now I can add the fractions. So 15 plus 14 divided by 20. So that gives me 29 over 20. Okay. Let's say that we want to subtract them now. Well, we go through the same process. So let's say we had 3/4 minus 7/10. Well, we already know what the least common denominator is between them, right? Which is still 20. That doesn't change. So I put this over 20 and I put this over 20. All right. And I already know that um, to get 20 here from the bottom, I had multiplied by 5, so 5 times 5 over 5. So 5 times 3 is still 15, and then 5 times 4 is still 20. And the same thing here, we're still going to do exactly the same thing. So it's the same process for addition as well as for subtraction. And I still get 7 times 2, which is 14, and 10 times 2 is 20. The only difference now is I'm just going to subtract them. So 15 minus 14 divided by 20, which gives us 120. Okay. So that's the only difference is now we're subtracting the numerator instead of adding them. Okay. So that's the same application here for the top. So in this case, when we add these variables, right, we want the least common denominator. So in this case, what would be the least common denominator for this here? What would that be? What's the least common denominator for that?
If we doing the letters,
Yeah.
would it be C?
Remember, we're looking at the denominator,
Oh, okay,
right?
okay.
Right? We're looking at the denominator. So what would be the least common denominator? What would be the common denominator? So for example, if I didn't know that 20, if 20 wasn't the least common denominator, what can I do with 3/4 plus 7/10? How do I find a common denominator between them? What was the other number that they have in common? Remember, 40 was another number that they have in common? Exactly. Yeah, right? So again, if I didn't know, I can just multiply these together. Again, it's going to be a little bit more work, but I should still get the same answer at the end. So 4 times 10 will be another denominator, but it's not the least common denominator between them. Okay? All right. So in this case here, right, B and D are the only variables there, so I have to use both of them. Okay, so the least common denominator for this one, the LCD for this one is BD. Okay, so that means then in order for me to have the same common denominator or to add them, I need to multiply this one by what? What do I multiply this term by? If I want BD as my denominator, what do I multiply this by?
Okay, so if you want BD to be your denominator,
Yeah,
you do
I
that
already have B.
one.
So what do I need left? What else do I need?
Oh, would it be A?
No, no, no. Remember,
Yeah.
BD is our least common denominator. That's the
Yeah.
denominator we want. We already have B. So what's left over? What do we need? Exactly. We need a D, right? Because we already have B. We need D here, right? So we're going to multiply this by D over D. Okay. How about over here? Okay. Again, I need BD. I already have D. What do I need so that we have the same common denominator? What is left? What do I need to multiply this by? Exactly. B, right? So I multiply this by B over B. Okay? Because again, we need B and D. We have that. Here is our B, here is our D. For this one here is our B, here is our D. Okay? Now we have the same common denominator. Now remember, when you're multiplying, right? I can do 2 times 3 is 6, correct? Or I can flip them. 3 times 2 is also 6, correct? So it doesn't matter the cumulative or commutative, all right? You can multiply either way. It doesn't matter. The result's going to be the same. 2 times 3 is the same thing as 3 times 2. So in this case, because we want to have this kind of in order, all right, so we want to put it in, we want to put it in order, so BD. So, I mean, you can write DB, that's fine, it doesn't matter. But in math, I like to have things in order. So I'll have this part here, I'll have AD over BD, right? This here is the same thing as this, they're just putting the letters in order. And then, and this one will be BC over BD. Okay. All right. Again, this is the same thing as this because of this, right? 2 times 3 is the same thing as 3 times 2. It doesn't matter the order, you'll get the same result. All right. So now I have this here, so I can add them. But again, the BD stays the same. I don't do anything to that. That's my denominator. And then the top will be AD plus BC. So that will be my answer for my unlike denominators for the variable. Okay. But again, if that's confusing, you just go back to what you know here and use the concrete example, and then just use the same principles of finding that to finding the one with just variables in it. Okay, so this one, they want us to find the greatest common factor. So for this one, there's two numbers between 3 and 27. What's the greatest common factor? For this one, 45, 105, what's the greatest common factor? And this one, there's three numbers. So we need to find the greatest common factor between those three numbers. Okay, so again, let me just show you an example on the first one, and then you can do the next two. So again, for 3, right? So the factors of 3 are going to be 1 and 3, and that's it, right? There's no other combination I can do to multiply two numbers that will give me 3. For 27, okay, there's a lot of them, right? So I can do 1 and 27, and then 3 and 9, right? So 1 times 27 is 27, and then 3 times 9 is also 27. Okay, so of course we have 1 to have in common, and they also have 3 in common, but we want the greatest common factor. All right, so in this case, the greatest common factor between them is going to be the 3. Okay, so that's going to be our answer here. So the greatest common factor between 3 and 27 is going to be 3. Okay, all right. So you're going to do exactly the same thing for these two examples. Okay, so go ahead and do that. All right, so we have 45 and 105, right? So let's break those down. So let me write down here. It's a different color here. All right, so we have 45, right? So the factors of 45 are 1, 45, okay? And we also have 3, 15, and we also have 5, 9, right? So those are the factors of 45. We do the same thing for 105. So 105 here, right? So that can be broken down to 1, 105, 3, and 35, and we have 5, 15, and we have, um, sorry, 5 and 21. 5 and 21, and then 7, 15. Okay. So again, we want there's, they have several common factors between them, but what we want is the greatest one. Okay. So in this case, the greatest one between 45 and 105 is going to be what? 15, right? 15 is the greatest common factor between those two. A lot of you guys wrote 5, but again, it's not the greatest common factor. Okay. All right. So the answer for this one, the greatest common factor between those two is going to be 15. Okay. All right. And then the last one here, 36, 48, and 72. All right. So again, let's do the same thing. We'll break them down. So we have 36. I'll do it over here. 36. Okay. So the factors of 36 are 1 and 36. We have 2 and 18. We have 3 and 12, and then 6 and 6. Okay. The factors of 48 are 1 and 48. Okay. 2 and 24. And then we have 4 and 12. And then the factors of 72 are 1 and 72, 6, 12, and then 8, 9. Okay. And then we want the greatest common factor between them. That would be 12, right? 12 is the biggest or the greatest common factor between those three numbers. So our GCF here is going to be 12, which many of you guys got. Okay. Okay, so for this set of questions, they want us to multiply the two terms and then simplify to the lowest terms. Okay, so again, we want to multiply the two terms and then simplify to the lowest terms. Okay. All right, so for this one, I'm going to show two ways. Okay. So for the first one, we can do exactly what it says. We need to multiply them and then simplify, right? So when we do that, 21 times 32 is going to give us 672, and then 32 divided times 21 will also give us 672. And when you divide them, it just equal to 1, right? So that's one way to do it. All right. The other way to do it is just start canceling things that are like terms. So in this case, we have 21 on the top, 21 on the bottom. So 21 can go into 21 one time. Same thing for this one, right? And and then 32 can go into 32 one time. And then this also is 1 as well. So then when I multiply fractions, I go directly across. So 1 times 1 is 1, and 1 times 1 at the bottom is also 1, which gives us 1. Okay? So you can also do it that way, where you can just start eliminating or start reducing it and then multiply across. Either way, whatever works with your brain. Okay? So both methods will work. So I'm going to do exactly the same thing here on this one. I'm going to reduce it because I know that 3 goes into 9 3 times, right? So again, 3 can go into 9 3 times, and then 3 can go into 3 one time. Okay? And then I can just multiply. So 7 times 1 is 7. Okay. And then I get what? 14 times 3. That gives us 42. Okay. And then I can reduce this. All right. So I can divide the top by 7. So 7 divided by 7, that's 6. The bottom I can also divide by 7. So 42 divided by 7. Okay, so 7 divided by 7 is 1, and then 42 divided by 7 is 6. Okay, so that's one way, or you can multiply it across, right? So 21, 7 times 3 is 21, and then 9 times 14 is 126. All right, and then that can be reduced to 1/6. Right, so either one. So whatever, again, works with your brain. Okay. All right, for number 3 here, so I have 5. I have whole number times a fraction. So remember, we can rewrite the whole number as in fraction form. So 5 is the same thing as saying 5 over 1, and then we can just multiply across. So 5 times 7, and then 1 times 9. So 5 times 7 is 35, and then 1 times 9 is going to give us 9, right? And then that can't let's see, can that be reduced more? No, okay. Um, so that we can't reduce that any further. So 35 over 9 would be our lowest term there. Okay. All right, this next one here, I'm gonna do the same thing. Notice that we have a y here and a y here, so we can cross those guys out. Okay. And I have x over z. Or again, I can do xy over yx. Sorry, yz, and then cancel out that way, and we get x over z. Okay. And then for the last one here, um, again, I can multiply across. So 5 times 4 is 20, and I still have the x there. And in the bottom there, I get 8 times 5, which is 40, and then I have the y. All right, so the x and y we can't eliminate them, so we leave them alone. But we can reduce 20 over 40, right? So 20 can go into 21 times. 20 can go into 42 times. So we have 1 over 1x times 2y. Okay, and then that would be our answer there. All right, so for this problem, they want us to find the least common denominator. All right, so the first one is 8/21 3/7. The second one is 1/9 5 over 12. The third one is 2/5 2/3 1/6. And the last one there is 2/15, 7 over 20, and 1 over 30, right? So we need to find the least common denominator for each of those problems. All right, so again, in this case, what we want to do is we want to find a common denominator between them so that they can go into them evenly. All right. So if I pick, 21, 21 can go into 21 evenly. But if I pick 7, 21 can't go into 7 evenly. Okay. So another way to look at it is you can do multiples of it, all right, of that number and find the lowest one between them. So in this case, we would have 7, 14, 21, 28, right? Those are multiples of 7. And then the 421, that would be what? 21, 42, 63. Okay. So as you can see, the lowest number that they both have in common has to be 21. Okay. So that has to be the LCD for both. It cannot be 7 because the lowest number we have for 21 is 7. Okay. And so, um, all right. So in this case, the LCD has to be 21. Okay. Now it's the same thing for this one, 9 and 12. Okay. So um if I pick if I pick 9 as my LCD, 12 cannot go into 9 evenly. 9 goes into 9 evenly, but 12 doesn't. Okay. So um so I need to pick um a different number that can go into evenly. Now, again, one thing you can do is you can multiply 9 and 12, all right, to get a common denominator. But again, it wants the least common denominator, so that wouldn't be the least one, because it would be 9 times 12 is 108, and that number is pretty big. So again, another way to do it is doing it multiples of that number. So, um, I can do 9, 18, 27, 36, right? Those are multiples of 9. For the same thing for 12, I can do 12, 24, 36, 48. Okay. So the least, the common factor between them, the least one is going to be 36, right? So that's going to be the least common denominator for both of them. All right. So it can't be 9, it can't be 12 because they can't go into each other evenly. So in this case, the least common denominator here is going to be 36, right? Or another way to look at it is, okay, I can multiply the 9. 9 times 4 is 36. And I also know that 12 times 4, sorry, 12 times 3 is 36. So that's another way to approach it. But can I multiply to both of them that can have the same they can have the same number. Okay. The next one, right now we have three denominators or three numbers that we need to be aware of. Okay. So again, I can multiply all them out if I want to, but again, that would not be the least common denominator. All right. Or I can do multiples of each one. Okay. So again, I can do 5, 10, 15, 20, 25, 30. All right. And I can do 3, 6, 9, 12, 15, dot, 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 through 30. And I can do the same thing here. 6, 12, 18, 24, 30. Okay. So notice here that the least common denominator or the least common factor between all three of them or common multiple, all three of them is going to be 30. So that's going to be our LCD is 30. Okay. Because again, they all have that. And that's the least one that they all share. Or I can multiply this by, 5 times 6 is 30, right? 3 times 10 is 30, and then 6 times 5 is also 30. So that's another way to do it. Okay. And then for the last one here, um, following that same method, the LCD for this one is going to be 60. Okay. Because again, I can do 15 times 4 is 60. I can do 20 times 3 is 60. And then 30 times 2 is 60. Okay. And then again, that will be the least common denominator between them. Okay, so for this one, they want us to rewrite each set of fractions with the least common denominator. All right, so now it's going to affect also the numerator. So we need to rewrite each one so that they will have the same common denominator, whether we're going to add them or subtract them. Okay, so this one's going to affect both the numerator and the denominator. So what we want to do here is we want to rewrite each set of fractions with the least common denominator. So we're going to rewrite this. So I'm going to focus on the denominator here first. So the first one here, we have 18 and 24. Okay. So one thing we can do is we can find multiples of it, right? That's been kind of the common theme here. So 18 times 1 is 18, right? So 18 times 1 is 18. 18 times 2 is going to give us 54. 18 times 3 will give us, sorry, I go back here. 36. 18 times 3 is 54. And then 18 times 4 is 72. All right, let's see how far that will take us. Let's do the same thing for this one. So we have 24 times 1 is 24. 24 times 2 is 48. Okay. 24 times 3 will give us 72. Okay. So it looks like 72 is going to be the least common denominator between them. All right. So what we need to do now is we need to make the denominator 72. So in this case, for this one, we multiply this by 4 to give us 72. So let's rewrite this. Okay. So we have 5 over 18, right? We multiplied the bottom there by 4 to give us 72. All right, so that means we need to do the same thing for the top. Okay, because again, we can't change the problem. It's just we need to rewrite it so we're able to find the LCD between them. All right, so 18 times 4 is 72, and then 5 times 4 is going to give us 20. So 20 over 72 is the first one, and then we do the same thing for the second one here. So we have 1 over 24, and we multiply it by 3 to give us 72. Okay, but again, what I do on the bottom, I must also do on the top, so that gives us 3 over 72. So this is what it's saying. We want to rewrite each set of fraction with the least common denominator. So we have done that here. Okay, for this one here, we do exactly the same thing. I can do multiples of each one. Or I can see that, 45 is a common denominator between the three, and it is the least common denominator between the three. So I can take the 4 over 14, multiply that by 3 over 3, and that will give me 12 over 45. I do the same thing for 2 ninths. 2 ninths, multiply that by 5 over 5. That will give me 10 over 45. And then same thing for the last one, 3/5 times that by 9 over 9. Okay, and that will give me 27 over 45. Right, so that's our answer there. So that would be our, we have rewritten each term with the least common denominator. Okay, so for this one, we want us to add or subtract. We're gonna have 7/8 minus 1/6 plus 5 over 12. Okay, so here we want to add or subtract here. So we have 7/8 minus 1/6 plus 5/12. So what did everybody get for their LCD? What's the LCD here? What do we get? 24. Good, excellent, right? So 24 is the LCD. So that means then I need to multiply each ones in the denominator so that the result is going to be 24. So for this one, for it to be 24, I multiply this by 3 over 3. Okay? 3 times 8 is 24. For this one, I have to multiply this by 4 over 4 because 4 times 6 is 24. And for this one, I have to multiply this by 2 over 2 because 2 times 12 is 24. All right, so when we do that, we get 21 over 24 minus 4 over 24 plus 10 over 24. Okay, so when we do that, we get what? 21 minus 4 is 17, plus 10 will give us 27. And the denominator stays the same. We don't do anything to that, right? So that will give us 27 over 24, whichever you got. Okay?
I have a question.
All right, so here it says you have the American flag, the blue rectangle containing the stars on the American flag is called the Union. On an official American flag, the width of the Union should be 7/13 of the width of the flag. If an official flag has a width of 32.5 inches, what is the width of the Union? Okay, so again, I think I told you I'm from the Philippines and um, English is my second language. So I'll read this. This probably goes over my head and I have to read it multiple times in order to stick to my brain. So if that didn't make sense the first time, then I encourage you to read it over and over until something sticks to your brain. Okay? So let's read it one more time. It says the blue rectangle containing the stars on the American flag is called the Union. On an official American flag, the width of the Union should be 7/13 of the width of the flag. So that's our key information here. It tells us that the width of the Union is 7/13 of the width of the flag. Okay. What's another word for of in math terms? What's another way we can represent of? Anybody remember? Not divide. Well, if you're thinking about fraction form, yes. But what's another way?
With
Because
adding?
it's of the width of the flag. 7/13 of the width of the flag. So for example, you know, I can say um, let me pause this for a second. All right, so again here we have the key part here is that 7/13 of the width of the flag. So in this case, of is referencing to being multiplied. And we already know the width of the flag. The width of the flag is 32 and 1/2. So it's telling us we take 7/13. Okay, we have 7/13. I can write here 7 over 13, and then we're going to multiply that by 32 and 1/2. Okay, so what we need to do is this is a proper fraction. We need to change it to an improper fraction. So remember to do that, you just multiply these two numbers here, the 32 and the 2, and then we add the 1. Okay, so that's going to give us 32 times 2, which is 64 plus 1, which gives us 65 over 2. Okay, and then we have the 7/13. Right? And then we multiply directly across, which we have been talking about. today. Okay, so so when we do that, 7 times 65 gives us 455. Oops. And then 13 times 2 will give us 26. Okay. All right. And then we can reduce that to 35 over 2 or 17.5. Okay. So the answer is the width of the union is 17.5 or 35 over 2. Does it say? Yeah, in inches. Okay. So that's our units there. So make sure you include that in your answer.